Homework 13 starts off with even and odd functions. An even function comes from graphing something like x squared. If I graph the graph x squared, it's a parabola, and it's that U shape that looks something like that. An even function is reflective across the y-axis. If I fold it right on the y-axis, they'd be right on top of each other each side. An odd function comes from graphing something like x cubed. An odd function, or the graph of x cubed, looks something sort of like that. They tell you that the graph of an odd function reflects across the y-axis, then the x-axis, and would end up right on top of each other. So if I reflected this across the y-axis, it would be coming up like this, and then if I flipped it back down here, then it's going to land down here right on top of this one. So kind of think about them having to be diagonally across from each other because they have to reflect across the y and then across the x and touch each other when you do that. So they want you to first of all look at your graphs and decide, is it even, is it odd, or is it neither? So if I took this and I cut it in half across the y-axis, is it exactly the same on both sides? Yes, it is. So it is going to be an even function. If I were going to check the next one, if I cut it right in half along the y-axis, it's not exactly the same on both sides, nor does it go across and then back down diagonally, because then it'd have to be down in here, and so this one's going to be a neither function. So even you should be able to cut it across with the y-axis. Odd's going to end up being diagonally because I have to go the y and then the x. Now there's a second part to that. They also have some equations or some functions want you to say if it's even, odd, or neither. If I don't have any parentheses, absolute values, special symbols in there, I can basically just look at the exponents. If all of my exponents are even, it's an even function. If they're all odd, it's an odd function. Something with x to the 0 power is an even one. 0, 2, 4 are even. 1, 3, 5 are odd. So 4, 2, and 0 are all even. This is going to be an even function. 3 and 5 are both odd. It's going to be an odd function. Now another way to check if it's an even or an odd function is to plug in values that are opposite each other. 1 and 2 don't really work very nice because there's too many cases, like when you square or take the absolute value, that you end up with the same numbers. And so I like to use 3 and -3 for my test values. What you would want to do is do 4 times 3 to the 4th minus 2 times 3 squared minus 4 and find your answer. Then 4 times -3 to the 4th minus 2 times -3 squared minus 4 and find your answer. So if I do that, now I'm just going to use my calculator. 4 parentheses 3, close my parentheses, to the 4th power minus 2 parentheses 3 parentheses squared minus 4 equals. I get 302. If I do the bottom one, 4 parentheses -3 parentheses to the 4th minus 2 parentheses -3 parentheses squared minus 4. Hey, I get 302. If I use my two opposite values, and you could do 3, 4, 5, bigger numbers than 1 or 2, but I like to use 3 and -3. If I get the same answer, it's an even function. We already knew it was an even function, but that's the way you test it if you can't tell by looking at it. So same thing over here. If I test this one, -2 times 3 to the 3rd plus 4 times 3 to the 5th, and -2 times -3 to the 3rd plus 4 times -3 to the 5th. If I punch those in, let's see what happens. So -2 parentheses 3, close my parentheses, cubed, plus 4 parentheses 3 parentheses to the 5th gives me 918. If I do the bottom, -2 parentheses -3 parentheses cubed plus 4 parentheses negative 3 parentheses to the 5th. I get negative 9/18. So notice on these values I have the same number, but they're opposites. When I plug in my two opposite values, if my answers are opposites, then it's an odd function, which we already knew. But sometimes you can't tell by looking at the equation, so you have to do the test, and I like to use 3 and negative 3. If you get the same number, it's even. If you get opposite numbers, it's odd. If you get two numbers that have nothing in common, it's neither. So on number 2, if I'm looking at that one, it is not split across the y-axis, otherwise it would have to go up this way. And it's not split across the y and then the x, because it would have to be going through the middle section. So this one's going to be a neither function. There's my cubic function, I can tell by looking at it. But here, if I split it here, this would go up like this, and then if I split it here, this is going to flip down here. If I could draw straight, that's my odd function. If you can think of in your mind, if it were on a piece of paper, if you folded this way, then folded this way, it would end up right on top of there. The next one I'm looking at, and I'm saying, okay, is it even, is it odd, is it neither? Well, I know this is to the first power, so it's odd. This is to the 0 power. 0 power means, oh, one's even, or one's odd and one's even, so I'm going to have to pick neither on this one. But if I really wasn't sure, I'd do my test. 2 times 3 minus 3, and 2 times negative 3 minus 3. Putting in 3 and negative 3 for my x's. So 6 minus 3 is 3. Negative 6 minus 3 is negative 9. You can see, oh yeah, I get two answers that have nothing in common. It's definitely a neither. Here again, I have a squared and I have a 0. 0 counts as an even. So it is an even function. But if I wasn't sure, 2 times 3 squared plus 4 and 2 times negative 3 squared plus 4. So 3 squared is 9. 9 times 2 is 18. 18 plus 4 would be 22. Here, negative 3 squared is 9. 2 times 9 is 18, and 18 plus 4 is 22. So if I do my 3 and my negative 3, I get the exact same answer. I know it's an even function. And if we look at the third one, looking at this one, again, it goes over here, then flips down here. That is an odd function, but it's in diagonal quadrants of each other, which gives you a good idea. This one, if it were right at the middle at 0, 0, it would be an even function, but it's not at 0, 0. It doesn't split in half. It's going to end up being a neither function. Now this one, when you look at it, you might think, oh, it has an odd exponent, but because it has that parentheses, you'd either have to take negative x minus 4 times negative x minus 4 times negative x minus 4 and get rid of the parentheses, or just do our test. So I'm just going to go ahead and do the test. I'm going to have minus 3 minus 4 cubed, and then I'm going to have minus a negative 3 minus 4 cubed. So this is going to give me negative 3 minus 4, which is negative 7. I have to cube negative 7. So negative 7 to the third power is negative 343. On this one, when I do minus a negative 3, it becomes positive 3. 3 minus 4 is negative 1, and negative 1 cubed is negative 1. I don't get the same answers. That's going to be a neither function. So if it has parentheses, absolute values, a fraction, anything other than a regular straight across function, I have to do my check to make sure. This one ends up being neither. Now this one I should be able to look at and say, oh, it's to the fourth and to the second. Both of those are even. Should be an even function. You can check it if you want to, but it should end up that if you do check it, you get the same number twice. 4, 5, and 6 talk about translating the graph of the function, and we referred to it when we were graphing absolute values and parabolas, that we have that shift. If it's in with the x, we have to say x plus 1 equals 0, and when we solve it, it moves it in the opposite direction. So this is going to move it to x equals negative 1. The number on the end is going to shift it up or down. It's going to go in the same direction as you normally do, because if I put negative 1 in here, negative 1 plus 1 is 0. I just get that end number. So this is going to shift it to the left 1 and down 2. Left 1, down 2. And then you're just going to grab it. They'll have this little finger tool. You move it back 1 and down 2, and then the computer's just going to redraw the graph however it should look once you've moved it over. So if I'm looking at number 5 and I'm looking at the translation, again, I have x minus 4 under my square root. So when I move that over, I'm going to plus the 4. X is going to equal 4 in order to make this 0. 4 minus 4 is 0, and then y is going to equal the end number minus 1. So my translation is that this is going to move it to the right 4, and this end number moves it down 1. So it's the opposite of this because I have to make it 0, but the same direction as that one. So I move it to the right, 1, 2, 3, 4, and down 1. I drop that point, and it's going to redraw my graph going over in that other direction. Number 6, same kind of thing if I'm looking at that. Here in with the x, x minus 1 would equal 0, so x would have to equal 1. This is actually going to move it to the right 1 then. Since it had a minus, it changes to a plus. And then this is going to stay, so it's going to go up 3. Y would equal 3 if x equals 1. 0 plus 3 is 3. So I'm going to move it over 1 and up 1, 2, 3. It's going to go there, and then my graph's going to redraw something sort of like that. So on my horizontal and vertical translation, horizontal, it's the opposite because I end up moving the number over. Vertical, whatever that number is on the end, that's going to move that center point up or down, up if it's positive, down if it's negative. So 7, 8, 9 are transforming the graph of a function by reflecting over an axis. Depending where the negative sign is, it's either going to reflect across the y-axis or across the x-axis. So if the negative is in the inside of parentheses with the x, that is going to reflect it across the y-axis. If the negative is in front of your function, like when we had negative 3 times the absolute value of something, I said it was going to flip it upside down, that's going to reflect it across the x-axis. So in this case, if this is my graph f of x, and I want to do f of negative x, this is going to reflect across the y-axis. So I might want to mark some points here. This one is at negative 4, negative 3. So at positive 4, negative 3, I'm going to have a point. This one right here is going to stay where it's at. If I do my end point, this one is at negative 7, negative 6. So at positive 7, negative 6, I'm going to have a point. And this one is at positive 4, negative 7. So at negative 4, negative 7, I'm going to have a point. So my graph now is going to look like this. Oops, if I could draw an end right there. And then that's how that's going to look. Of course, they won't let you on Alex go past that end mark or they will count it wrong. So you want to draw a little straighter than I did. But my graph is going to look something like that. This point is opposite that point. 1, 2, 3, 4, 1, 2, 3, 4. This point is opposite this point. 1, 2, 3, 4, 1, 2, 3, 4. And this one is opposite this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So if it's in with the x, it goes across the y-axis. If it's on the outside, it's going to go across the x-axis. So number 6, This one's on the outside. Y equals negative f of x. So that means it's going to reflect it across the x-axis. So this point here is going to be down here, right? It was up 2, now it's down 2. This point, 1, 2, 3, 4. So 1, 2, 3, 4. This point, 1, 2, 3, 4. So 1, 2, 3. Did I count wrong? 1, 2, 3, 4. 1, 2, 3, 4. There. Should be straight across. And this one is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And so now it's going to go down, across, and down. And again, if I fold it across here, this would be right on top of there. And number 9. Same thing. Now looking at this one, the negative is on the outside. Since it's on the outside, it's going to reflect it across the x-axis. So this point's going to come down here. This one, 1, 2, 3, 4, will be 1, 2, 3, 4 down. And this one here is going to be in the same spot. That one's going to go up there. So it's going to go down and then go back up and look something sort of like that. So if the negative's on the inside with the x, it goes across the y-axis. If it's on the outside of the f of x, then it goes across the x-axis. Now 10, 11, and 12 are giving you the pictures of the two graphs, and they want you to rewrite what the equation should be. So keep in mind that if I have x minus something, it went to the right. If I had x plus something, it went to the left. If I had a plus number on the end, it went up. And if I had a minus number on the end, it went down. And so what we want to do is look at the graph. The original graph is always starting at 0, 0. This is the graph of x squared. We want to translate our graph 2 to the right and down 3. 2 to the right and down 3. So we know that with our x, we have to do x minus 2 in order to make it go 2 to the right. In order to go down 3, we're going to have a minus 3 on the end. But we have to look at our original graph. On our original graph, it was a squared one, which means the x part of this has to be squared. And so k of x, which is our new function, is going to be equal to x minus 2 squared minus 3. And that's going to be my new equation. So on number 11, if I look at this graph, this is an absolute value function. I want this graph to go 1, 2 to the right and 1, 2, 3, 4 down. So 2 to the right, 4 down. So if I'm going to go 2 to the right, I'm going to do x minus 2. If I'm going to go 4 down, I'm going to have a minus 4. But in this case, my x has the absolute values around it. So if I'm going to do k of x, I really don't need the parentheses since I have the absolute value. I'm going to have x minus 2 minus 4, and that would translate my graph 2 to the right, down 4. Number 12. This time we have a square root function. Always the original one starts at 0, 0 because there's no shift to it. So this one we want to go 1, 2, 3 to the left and 1, 2, 3, 4 up. Left 3, up 4. 3 to the left, up 4. So left 3 means I'd have to have x plus 3. Up 4 means a plus 4. This one has a square root over the x part of it. So again, for k of x, Since this is under the square root, we really don't need the parentheses. It doesn't hurt if you put them there. But I have the square root of x plus 3 on the outside of the square root, so make sure you hit the space bar and get off of the square root. The plus 4 is going to go on the end. I should probably circle that. So my new equation, that shifts it 3 to the left, up 4, x plus 3, and plus 4. So 13, 14, 15, doing the sum, difference, and product of two functions. Here, s plus t, I'm adding my functions. Here, s times t, I'm going to multiply them. Here, s minus t, I'm going to subtract them. And I'm going to evaluate it at x equals 4, which we'll get to. So first of all, if I'm going to add, I'm going to take my s function, which is the 3x plus 6. I'm going to add my t function, which is the 4x. Now, since I'm adding, I really didn't need the parentheses, but I put them there because the order is important when you subtract, not necessarily when you add. So I'm going to combine my like terms. 3x plus 4x is 7x, and so I get 7x plus 6, and there's nothing else I can do to simplify that, so that's just going to be my answer. Now, on the next one, I'm going to do the s times the t. So I'm going to take the 3x plus 6 times the 4x. And since I'm multiplying, I end up using my distributive property there. 3x times 4x is 12x squared. 6 times 4x is 24x. I don't have any like terms, so 12x squared plus 24x is going to be my answer. Now on the second one, you can either subtract them first and then put the 4 in, or put the 4 in and subtract them. Just for fun, if I do it this way, s 3x plus 6 minus the 4x. I have to distribute my negative, so I'm going to take 3x plus 6 minus 4x, which gives me negative x plus 6. I'm then going to evaluate that answer at 4. So if I would put a 4 in for my x, I would have negative 4 plus 6, which is 2 for my answer. Now the other thing I could have done is I could have put the 4 into the original expressions. 3 times 4 plus 6 would have given me 12 plus 6, which is 18. Then put the 4 in my other expression. 4 times 4 is 16. Tells me I'm going to subtract those two values. 18 minus 16 is the same 2. So you can see it works either way. I just kind of like to be consistent as how I do the problems. So I usually do the evaluation first, then put the number in and solve it at the end. Not that it makes a difference. So if I look at the next one, I'm doing s plus t. So s is the x to the third plus the t, which is the 3x squared. Now here I don't have any like terms. I really can't do anything. So I just get the x to the third plus the 3x squared, and that's going to be my answer. The next one says to do s minus t. So I'm going to do the x to the third. I'm going to minus the 3x squared. And I use the parentheses because on the negative, if that was a binomial, you'd have to distribute it out, and you want to make sure you get your signs changed. On this one, it's not going to make much difference. I just get x to the third minus 3x squared. They're not like terms, so that's just going to be my answer. On the last one, I'm going to do s times t. So I'm going to take my x to the third times my 3x squared, which would give me 3x to the fifth power. I'm then going to evaluate that at negative 1. So 3 times negative 1 to the fifth. Well, negative 1 to the fifth is still negative 1. Negative 1 times 3 gives me negative 3 for my answer. I got to remember, follow my order of operations, so do exponents then multiply. Same thing here. I could have put the negative 1 in each of these separately and then multiplied my answers. Negative 1 cubed is negative 1. 3 times negative 1 squared. Negative 1 squared is a positive 1. 1 times 3 is 3. And then multiplied my answers. Negative 1 times 3 gave me that same answer of negative 3. So if you want to double check, you can do it both ways. Number 15. I'm going to do s times t first. So I'm going to take x plus 5 times my 2x squared. And again, I'm going to have to use my distributive property. So I'm going to get 2x to the third plus 10x to the second. And again, not like terms, so I can't do anything other than distribute it out, multiply it out. The next one tells me I'm going to add x plus 5 plus my 2x squared. Here I don't have any like terms that I can combine. However, I could rearrange the order so it was in the best order. So 2x squared plus x plus 5. Just going to end up being my answer on that one. For the s minus t, I'm going to take x plus 5 and I'm going to subtract my 2x squared. Again, I really don't need the parentheses since there's only one term there, but if it were a binomial or a trinomial, I need for sure to use the parentheses, so I'm going to put them there. Putting this in the best order, I'd have negative 2x squared plus x plus 5. But this one is the one we're going to evaluate at 4. So negative 2 times 4 squared plus 4 plus 5. 4 squared is 16. Negative 2 times 16 is negative 32. Plus 4 plus 5. So negative 32 plus 9 gives me negative 23 for my answer. And again, if I wanted to double check that, I could put those in here. 4 plus 5 is 9. 2 times 4 squared would be 16 times 2, which is 32. 9 minus 32 gives me the same number I got down there, so I know that I did it correctly. (16, 17, and 18), we're doing the composition of two functions. This is read w of u of 5. What we're going to do is basically kind of go backwards. We're going to figure out what the u of 5 is first. So u of 5, in the u function, we're going to put a 5. 2 times 5 minus 2. So that would give me 10. 10 minus 2 is 8. Once I get that answer, I'm then going to do w of the 8, which is what I've got for my answer there. So w of 8 says I'm going to take negative 8 squared. Following my order of operations, I've got to square the 8 first and then put the negative on there. 8 squared is 64, so I get negative 64. That's going to be my answer to that question. So I've got to do 2 steps in order to get the answer. Then I do the next one. The next one starts out and says I'm going to do the w of 5 first. So w of 5 means I'm going to do negative 5 squared. 5 squared is 25 and the negative goes in front. I'm then going to do u of that answer, so I'm going to do u of negative 25. So I'm going to take 2 times negative 25 minus 2. This would give me negative 50 minus 2, so negative 52 is going to be my answer. So I kind of work my way backwards. I put the number into the closest one first, take the answer and put it into the next one. So number 17, same kind of thing. This one's going to start out, I'm going to do r of 4 first. So in my r function, which happens to be the second one, so I'm going to take 4 squared plus 5. 16 plus 5 gives me 21. So now I'm going to do q of 21. So I'm going to do the square root of 21 plus 4. Well, 21 plus 4 is 25. That one happens to be a nice perfect square. The square root of 25 is 5. So 5 is going to end up being my first answer. Sneak the next one in here. I'm going to start with the Q of 4 in this case. Q of 4 means I'm doing the square root of 4 plus 4, which is the square root of 8. Now I could simplify the square root of 8, but since I'm not to the end, I'm going to leave it like that. So I'm going to do r of the square root of 8, which means I'm going to take the square root of 8 squared plus 5. Now when I square a square root, that cancels that out, so I just get 8 plus 5. So 13 is going to be my second answer. Number 18, same kind of thing. I'm first going to do t of negative 2. So t of negative 2 means I'm going to do negative 4 times negative 2 plus 3, putting the negative 2 in for the x on my t function. So I'm going to have 8 plus 3 gives me 11. I'm then going to do s of 11. So I'm going to take negative 3 times 11 plus 1. So negative 33 plus 1 gives me an answer of negative 32. And that's going to be my first answer after I do both steps. On my next one, I'm going to start with the s of negative 2. So s of negative 2, in my s function, negative 3 times negative 2 plus 1. This would be 6 plus 1, which is 7. So now I have to do the t of the 7. So negative 4 times 7 plus 3. Negative 28 plus 3 gives me negative 25, and that's going to be my second answer.